In this video, we're going to have a look at how to solve equations that involve factorization. Up to now, we've had a look at linear equations and equations in the form a times b equals 0. For linear equations, we did the inverse operation on both sides of the equation to solve the equation, and here we always get one solution. For equations in the form a times b equals 0, we saw that either of the two factors can be equal to 0 for the equation to be true. And that means that the number of factors indicate the number of possible solutions. The degree of an equation, meaning the biggest exponent in the equation, also indicates the number of possible answers. So when you are given an equation with a degree of bigger than 1, it means it's not a linear equation. Then you will have to factorize that equation so that you can use those factors to determine the solutions. Let's go and have a look at some examples. Solve x, example 1. In this example, we have an equation with a degree of 2, and this means that there will be 2 solutions. To determine those solutions, we need to break this equation up into its factors. So we will have to factorize. Here we have a binomial, and in these two terms, the common factor is x. So I'm going to start off by taking x out as a common factor, and then I'll be left with x minus 4. If you first need to revise factorization, you can follow the link in the description to the factorization videos. Here we've now rewritten this equation in the form a times b equals 0. So that means we know that either of the two factors can be 0. So x can be equal to 0, or x minus 4 can be equal to 0. So my final answers will be either x is 0 or x is equal to 4. In example 2, we once again have a degree of 2, and that means our first aim is to rewrite this equation in the form a times b equals 0. So the first important part is to realize that this equation should equal 0. That means we need to subtract 16 on both sides. Now that we have the equation equal to 0, we can factorize the left-hand side, and here we have a difference between squares. So we will form the brackets x minus 4 times by x plus 4. And now we can once again say that either the first factor can be equal to 0 or the second factor can be equal to 0. So our final answer here, x is 4 or x is minus 4. In example 3, we once again have an equation that needs to be factorized because we have a degree that is bigger than 1. In this case, however, the right-hand side is already equal to 0, so we can immediately factorize. On the left-hand side, we have a trinomial which we can factorize into 2 brackets using the factors of 10. So the 2 brackets will be x plus 5 times x plus 2. Next, I can take each individual factor and equate it to 0, and that means that my final answers will be x is minus 5 or x is equal to minus 2. In example 4, I once again want to rewrite the equation in the form a times b equals 0. That means that my first step will be to get everything on one side by subtracting the 24 to get a 0 on the right-hand side. Now we can factorize the left-hand side, and the first step will be to take out a common factor. The common factor here can either be 2 or minus 2. When I take out minus 2, I'm left with x to the power of 2 minus 7x plus 12. And I chose to remove the minus 2 because now the trinomial in my bracket is one that I can easily factorize. The trinomial can now factorize into the brackets x minus 3 times x minus 4. And now the equation is written in the form a times b times c equals 0. So any of these factors can be equal to 0. The first factor of minus 2 cannot be equal to 0. So I'm only going to use the second factor, x minus 3 can be 0, or x minus 4 can be 0. And this means that x is either equal to 3 or equal to 4. When working with an equation, you can also choose to, rather than taking out a common factor, divide by that common factor straight through. As long as you remember to do whatever you do on the left-hand side, on the right-hand side as well. So here we could have chosen to, after the first step, rather divide by the common factor of minus 2. Then we would have had x squared minus 7x plus 12, and on the right hand side still equal to 0. Next, I would still factorize into the brackets x minus 3 times x minus 4, which means I would have still gotten the same two answers. In example 5, we already have an equation equal to 0, so we can immediately start factorizing. Here we can remove a common factor of 2x, and then we are left with x squared minus 9. It is important to realize that here I could not divide both sides by that common factor, because in this case the common factor also consists of the variable that I need to solve. That means I cannot divide by it. The bracket of x squared minus 9 can now once again be factorized because we have difference between squares. So I will form two brackets, and it will be x minus 3 and x plus 3. So again, we have the form a times b times c is equal to 0. This means that either the first factor of 2x can be equal to 0, or the second factor of x minus 3 can be equal to 0, or the third factor of x plus 3. And that means that x can either be equal to 0, or equal to 3, or equal to minus 3.